Hello student. Today we will see distance vector routing protocol. It is also used to measure the shortest path between the nodes. Distance vector routing DVR protocol requires that a route information its neighbor of topologies change periodically. Historically known as an old apparent routing table. It is also called as a Boltzmann basis. Each router maintains a distance vector table containing the distance between itself and all possible nodes. The distance based on the choice that the, the distance based on the chosen matrix are compared with the information of the neighboring distance vector. Information used kept by the DV router, its ID, then associated with each link connected to the route that link cost intermediate hop. Then distance vector algorithm, distance vector table information, distance to self 0, distance to all of the other nodes that is not nearer to it is considered as an infinity. Each router maintains the distance vector to each neighbor in the route packet. Each router receive and save a most recent received distance vector from each of its neighbor. A router recalculated distance vector, then the receive a distance vector from a neighbor containing the different information than the before. It discover that the link has a neighbor has been goes down. Means what? We will explain with the help of the diagram. Okay, this is the explain with the help of a example. Now see, consider there are three router XYZ. Router maintain its table. Each router maintain it is table. How it's maintained the table? See here. Here vertically and horizontally writing the name of the routers. So XYZ are the table maintained for each of the router. Then with respect to X1 is directly connected to the Y with the help of one cost, whereas x to x is 0. Cost is nothing but a distance in the form of distance that we can understood. So from agar hum if we want to go from x to x, its value of course is 0. X to y it is 1 and x to z it is 5. Then likewise y also maintaining its table, that is y is equal to y to y 0, y to x 1, y to z 2. Again same for the z z to z 0, z to y 2, z to x 5. Okay, after that this table will find out its neighbor and complete the table. That how it complete the table, see, I will explain first of all and then we will see. So for x1, now what we want to calculate? Y to x. So we have a table, so this y share the table with the x. So this one is a 10x. Okay, so while x to y, sorry, x to y the distance is 1, so it will be maintained as 1. Then y to y 0, y to z is 2. If it is 2, if it is 2, y to z if it is 2, then x knows x to y distance is 1 and y to z distance is 2, so it will be update the nearest table is 3. So x maintain the table 3. Likewise same for the y and z. First of all we will complete the table x only. So z to x, z to x is a 5 is given, 5 is given, but now we are calculating the shortest distance by 2 only, so it will be written as a 3. Then z to y, z to y, this distance is 2. So here z to y, no need of calculating x, that is why directly is written as 0, and x z to z 0. Likewise, remaining table are confirmed with the help of this diagram. Then it will be maintain the x, then is kept the record of x. So x is 0 1 3 0 1 3, here also 0 1 3. Y table is 1 0 1 1 0 1 1 0 2, sorry 1 0 2 1 0 2 1 0 2. Z is 3 2 0 3 2 0 3 2 0. So likewise it complete all the tables associated with this one. Again, one example for the distance vector algorithm we will take. Okay, what is the advantages? It's a simpler. Disadvantages, very slow process. Then it may goes to the counting to the infinity problems. We will explain these things in detail. Miss, if anyone notes is failed, then routing table will be changes, and so it create the problems, that infinity problems will be occurring. To create a matrix, then the link state, since hope counting changes must be propagated to all routing and proceed to the each other. The large network distance, if there, it required a large time to maintain the state, and large table it be required. Now one of the example. See here, n2, n3, n4, n5 are the five nodes or routers. So each router maintain the table. It maintain the table with the help of distance, destination, distance, and a next hop. So we will see for the n1, it will write the destination n1, n2, n3, n4, n5. Okay, so n1 is directly connected to the n2. That is why if it is n1 to n1 means we are n1 here, and n1 distance is 0. n1 to n2 distance is 1. Now n1 is not directly connected to the n3, n4, n5. That is why we are writing here infinity, infinity, infinity. If it is infinity, so see, n1 to n1 we are going, the next hope is n1, n2 to n2 next hope is n2. अगर हम n2 तक आए तो value is only n2. So n1 to n3 it is infinity, so we don't have any next hope. That is why it is a 0 0 0. That is a dash 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 there. Likewise, we are maintaining this n to n2. So writing 1 2 3 n1 n2 n3 n4 n5. Distance is from n2, n1 to n1 n2 0 1, n2 to n2 0, then n2 to n3 6, n2 to n4 n2, no, n2 to n4 we don't know the distance, that is why here we are writing as an infinity. Then n2 to n5 is a 3. Then see here, next hope means when we are going to the n1, n2, n3, if it is infinity, we are not knowing the next hope, and n5 to n5, we are writing here n5. Similarly, we are completing all the table. Now, whatever the value of infinity is to be given, we want to implement that one. How it will be implemented? See here, n1 will mm, uh, will update its table with the help of its neighboring table. So what is n2 do? N2, this this distance will be shared with the n1, so that n1, if there is a possibility to update the table, it will be update the table. So it has a value 0 1. So with respect to n3, so here n3 is 6 is given, but n1 to n2, he know the distance between n1 and n2 is a 1, so it written as a 7. So infinity is now converted into the 7 and 3. n3, and it will be update its table is from n2, only n2, because through n2 here the next hope is n2, and then it will be go to the then n4. So here is the infinity, so no change will be there. Then n5 is a 3 here, so it is written as a 4 here. Likewise, each and every node will update its table first round. So see here are 3 infinity numbers is there. Now only one is remaining. Likewise, other is also maintaining the table, sharing the table. For example, see here for the n2. So we are making the n2 table. And n2 table will share the n5 and n3. So this one is a n5, and this one is a n2. बराबर है n2. Then see here n1, n2, n3 is given. So how to find out n4? N4 to from n5 it is 4, it is 2. So n1 to n5 distance is 3, and 3 to 4 it is 7, and from n2 to n3 is a 6, and n3 to n4 is a 2, is 8. So it is from this distance we are going up to the n4 is 8, and here is a 7, so we will update with the shortest is a 7. Then n5 is given, so it will be complete the table. Likewise other tables is also fill up, and Mrs. share the distance from the neighborer one, and by using that distances is count the shortest path, and that will be implemented in the table. And when we'll going from this one, it update its table through that point, means through here n5 is there, so here n5 is there, through n5 the root is there. Okay, so likewise all the tables are be fulfilled by using the distance vector algorithm. Okay, thank you.